Good morning, everyone. In the previous lecture, we have already discussed about economic load dispatch. So, in this lecture, we are going to discuss about economic load dispatch and the tariff, which is a part of economic load dispatch. So, in the previous lecture, we have already discussed the different type of loads, what kind of load we are using, what are the connected load, what is your demand factor, what is your capacity factor. In this lecture, we will discuss few definitions which we have not discussed in the previous lecture, and after that, we will discuss uh, what is tariff and different parts of tariff. So, the learning objective of this subject is that to understand the different type of tariff and what is the economic load dispatch and what are the different kinds of loads. So after this lecture, I'm expecting from student that student would be able to understand the load factor, capacity factor, demand factor, and the different kind of tariff, and how we charge for electricity. Okay, so these are the contents of this lecture. Tariff requirements of a tariff, economics of power generation, and power plant site selection and problem. So, learning objective to understand the concept of economic load dispatch and learning outcome we have already discussed. So, first we will discuss in the chapter that what is your plant capacity factor. So, plant capacity factor is equal to E upon C into T, where E is the energy which is produced in kilowatt hour in a given period, and C is the capacity of the plant given kilowatt. T is your total number of hours in the given period. So plant use factor, it is defined as the ratio of actual energy produced to the maximum possible energy that could have been produced during the actual number of hours the plant was in operation. So basically, plant capacity factor, if we define these three particular words in different way. So plant means which is producing your electricity in technical terms, what its capacity, how much electricity it can generate. So energy produced in kilowatt hour is divided by capacity of the power kilowatt into total number of hours. Okay. So, plant use factor, it is defined as the ratio of actual energy produced to the maximum possible energy that could have been produced during the actual number of hours the plant was in operation. So, plant use factor E is equal to E upon C into T1. So, actual hours which is we are using. Okay. In the next lecture, we will do some numerical, which is based on plant capacity factor. Capacity factor. So it would help you to understand that what is your plant capacity factor. So next is your where E is energy produced in a given period. C is your capacity of the plant in kilowatt. T1 is equal to actual number of hours the plant has been in operation. And what is your maximum demand? It is the maximum load which a consumer uses at any time. It can be less than or equal to 100 load. If all the devices fitted in consumer's house run to their fullest extent simultaneously, then the maximum demand will be equal to connected load. Next is your load curve. So, what is a load curve? It is a representation between load in kilowatt and time in hours. That is shows variation of load on the power station. So, what is load curve? Now, let's come to the point what is tariff. So, energy rates are different methods of charging the consumers for the consumption of electricity. So it is desirable to charge the consumer according to his maximum demand and energy consumed. So the charge which is taken from consumer, which is based on your maximum demand of the consumer and the how much electricity or how much energy it is consuming. So the tariff chosen should recover the fixed cost, operating cost, and profit, etc. So requirement of tariff. The tariff should satisfy the following requirements. It should be easier to understand. It should provide low rates for high consumption. It should encourage the consumers having high load factors. It should take into account maximum demand charges and energy charges. It should provide less charges for power connection than for lightning. It should avoid the complication of separate wiring and metering connections. So, what is your economic of power generation? Economy is the main principal design of power plant. Power plant economics is important in controlling the total power cost to the consumer. The cost of power generation can be reduced by selecting equipment of longer life. So, economic of power generation is basically economy is the main point of any power plant. So economy is the main principal design of power plant. So power plant economic is very important in controlling the total power cost. So the cost of power generation can be reduced by selecting what should we always want that the things we are getting at should be it should be at very cheaper or minimum cost. So to minimize the electricity cost, there are few points which must be considered for the economic of power generation. So number one point is selecting equipment of longer life. If you are selecting equipment which has no longer life, so again and again, you have to maintain those equipments and you have to pay charges for that. And if they are not having their proper capacities or not utilizing their proper capacities, so uh, we will be in loss and the cost of electricity will be high. Second is you're running the power station at high load factor. So increasing the efficiency of the power plant, carrying out proper maintenance of plant equipment to avoid plant breakdowns, keeping proper supervision because good supervision is reflected in lesser breakdowns and extended power plant life, using a plant of simple design that does not need highly skilled personnel. Using a plant of simple design that does not need highly skilled personnel. So next point is here how we can select the power plant site selection. So the power plant sites should satisfy the following requirements. Cost of land as well as taxes on land should be low, and it should be nearer to load center so that cost of transmitting energy is low. It should be accessible by road, rail, or sea so that transportation of fuel, etc., is easier. Sufficient quantity of cooling water should be available near the site. 5. The site selection should be away from thickly populated areas in order to avoid atmospheric pollution and to reduce noise. Next point is the sufficient space for future expansion of power station should be available near the site. So site subsoil conditions should be such that foundation can be made at reasonable depth. So let's start and let understand these all points with a problem. So problem number one, a power station has a maximum demand of 80 into 10 to the power 8 kilowatt and daily load curve is defined as follows. So load curve we have already discussed. Load curve is always plotted with time in the load, and on y-axis we always take the load which is in always kilowatt or megawatt. On x-axis we always take time. So a power station has a maximum demand of 80 into 10 to the power 8 kilowatt and daily load curve is given. 0 to 6 hours the load is 40 kilo megawatt, 6 to 8 hours the load is 50 megawatt, 8 to 12 hours the load is your 60 megawatt, 12 to 14, that is your 50 megawatt. 14 to 18, that is 70, and 18 to 22, it is 80 megawatt, and 22 to 24, that is your 40 megawatt. So determine the load factor of power station. So this is our solution. Maximum demand is already given, so we have to find out load factor. For this, we have to first calculate the energy, then we have to calculate the average load. After calculating average load, maximum demand, and energy, you can easily calculate the load factor. So what is your maximum demand, which is your 80 into 10 to the power 3 kilowatt. So energy generated 40 into 6 plus 50 into 2 plus 60 into 40. So what we are doing, 40 kilowatt is load for 6 hours, and 6 to 8. For 2 hours, you are using 50 megawatt. 8 to 12 means 4 hours you are using 60 megawatt, and 12 to 14, again 2 hours you are using 50 megawatt. Okay, and then next 4 hours you are using 70 megawatt. Next 4 hours you are again using 80 megawatt, and next 2 hours you are using 40 megawatt. So like this you have calculated all the megawatts, and if you multiply this megawatt into hours, you will get the energy. So the energy which is consumed, that is your 1360 megawatt hour. So the energy consumed, that is your 1360 into 10 to the power 3 kilowatt hour. And average load is equal to energy generated divided by 24. So a load factor is equal to average load upon maximum demand. So that is equal to 0.71. So by using this formula, and load factor is always less than 1, because maximum demand is always greater than your average load. So that's why you are getting here 0.71, which is your load factor, and which is less than 1. So next problem is, our central power station has annual factor as follows. So load factor is equal to 60%, and capacity factor is given 40%, use factor is given 45%, and maximum demand is given 15,000 kilowatt. So first, what you have to do, you have to determine annual energy prediction, reverse capacity over the hour peak load, and hours per year not in service, and load factor is equal to 60%, and capacity factor is equal to 40%, and use factor 45%. So maximum demand is given this. So now we can solve this. First, you have to find out annual energy consumption in kilowatt hour, reserve capacity over and above peak load, hours per year not in service. So load factor is equal to average load upon maximum demand, and average load is equal to load factor into maximum demand. Load factor is equal to 0.6 into 15,000, that is equal to 9,000 kilowatt. Okay, and the next one is your annual energy produced, that is your average load into total hours in 1 year. So total hours in 1 year, if you divide it 365 days into 24, you will get 8760 total hours in a year. So the 900 megawatt can be multiplied by 8760, and you will get 78.84 into 10 to the power 6 kilowatt hour. So the annual energy prediction is 78.84 into 10 to the power 6 kilowatt. So this is all about your problem 2, and like this you can also calculate the capacity factor, which is equal to E upon C into T. C is equal to E upon capacity factor. Capacity factor is already given, that is your 40%. So you are taking here 0.4 into 8760. So the point is, you have to remember these formulas to calculate the different values, which is used to analysis the power plant, or which is used to for the economic of power plant. So this is all about your power plant economics. So next problem is, of time is also a form of energy like heat. Okay, so these are the form of energy. This is the unit of energy which is generally used in electrical system, which is your kilowatt hour, watt hour, whatever. Next, next is work done. It is applied force times distance covered. Its unit is Newton into meter, and the thermal energy is also a form of work done. Its unit is in joule. After the famous scientist Joule, who discovered that energy and work are equivalent, it is also at times expressed in the heat unit of calories. So 1 calorie is equal to 4.186 joule. So electrical work is the product of voltage difference and the current that flows. So what is equal to the current which is flowing multiply by the voltage difference. So what is equal to V into I? Okay. So it can also represented by joule per second. Okay. So what is equal to joule per second, and what is your the work which is performed in terms of electrical. So the unit of work is your volt into amperes, and you can represent it in a joule, which is joule per second. Now we come to the power plants. So first we have to understand that how we will decide the capacity of a power plant. So it is depend on upon your the load demand. How much load is connected to through this power plant, how much appliances are connected to this power plant, and how much we do some future analysis. Okay, that how much power plants is going to connect, how much appliances is going to connected in future. So the power plant capacity, it depends upon a number of terms, in which one of them is installed capacity. So it is the designed power generation capacity of a plant. It is expressed in terms of energy generated per unit time. So megawatt electric is the most commonly used term for electricity generating plants. Okay, so we use generally megawatt terms because there is a large power of generation which is in megawatt in power plants. That's why we called megawatt electric generation. So megawatt electric is the most commonly used term for electricity generating plants. So in case of process steam plant, it is either expressed in amount of steam generated per unit time or in megawatt thermal. Okay, so if you talk about like steam plant, so it is either can be expressed in the amount of steam which is generated per unit time. Okay, so this is all about your installed capacity, which is generally in terms of megawatt, or if you want to express in steam, that you can express in kilogram per second or megawatt thermal. Okay, so this is your power plant capacity or installed capacity. Now we come to the next point, that is efficiency. If you are installing a power plant, obviously you have to find out the efficiency, that this power plant is working efficiently or not. So for this, you have to calculate the efficiency of power plant. So there are few calculations which is used to find out the efficiency of power plant. So one of them is heat rate. So it is the amount of energy we have already discussed, that the unit of energy you can represent it in kilowatt hour, or the energy you can represent it in kilojoule. So it is the amount of energy that the fuel must supply to produce unit amount of electrical energy. Okay, so heat rate means that you are supplying, suppose 1 kilojoule, you are supplying, it is a uh, it is the energy, suppose in joule you are the fuel is supplying, and the production of unit amount of electrical energy in kilowatt hour. So it is expressed as kilojoule per kilowatt hour. That is your heat rate. Okay, hope you can understand. Suppose that the amount of energy is in kilojoule, and that from that amount of energy you are getting, suppose 1 kilowatt hour power, 1 kilowatt hour unit. Okay, so 1 kilowatt hour unit means one unit. If you are getting 2 kilowatt hour, that it means your 2 unit. Okay, so this amount of energy, from this amount of energy you are getting the unit, that is your heat rate. So heat rate can be expressed that this amount of fuel is you are burning, and after that you are getting this amount of electricity is produced. So the heat rate is equal to kilojoule per kilowatt hour. It is the ratio of energy divided by the unit, or you can say the electricity which is producing, okay, from the burning of fuel. Now, next come to the turbine heat rate. So it is the amount of heat steam must deliver to produce unit of heat. So actually in thermal power plant you are burning coal. So the how much coal is required to convert water into steam. So it is the amount of heat steam or BTU must deliver to produce unit of heat kilowatt hour. Now, it gives the thermodynamic efficiency of the steam cycle, but it does not include the boiler efficiency. Okay, so this is about the efficiency which must be calculated of a power plant. Okay, next point is the efficiency again can be divided into two parts. That is, one is your thermal efficiency. So it is the amount of heat carried by the steam per unit amount of heat delivered through the fuel. Next is your combustion efficiency. Okay, so hope you can understand what is thermal efficiency. So thermal efficiency, that is the your heat. Okay, that is your heat which is carried by the steam per unit amount of heat delivered through the fuel. And combustion efficiency, that how much energy you are getting after combustion of fuel, that is your combustion efficiency. Okay, so what is the difference between thermal efficiency and combustion efficiency? In combustion efficiency, in combustion efficiency you are uh, getting heat from the fuel, and how much heat you require, and how much heat you require to convert that water into steam, that comes into the thermal efficiency. You can say that how much heat you are using, which you are getting from combustion of the coal. So this is the basic difference between these thermal efficiency and combustion efficiency. So combustion efficiency, it is the ratio of the amount of energy or heat released by the fuel and the energy continued contained in the fuel burned. Okay, so this is your combustion efficiency and thermal efficiency. Let's come to the next point. Now, this is very important diagram. So you can see that there are 4 units. So every power plants have 3, 4, 5 as according to the requirement or according to the load demand, they have units. So each unit has his own generator. So suppose in this diagram you can see that there are 4 units and 4 generators and different type of consumers. So some units are supplying some of consumers, which is customer one and customer two. Uh, Unit 2 and Unit 3 is applying different customers, and Unit 4 is supplying electrical energy to different customers. So this is your load distribution. We will discuss in detail in our next slide. So this is a graph or a diagram of your load distribution. Next, we come to the base load and peak load. So, what is base load? Base load is your the constant load. Okay, the load which is not changing with the time. That is your base load. Okay, so base load is not changing with the time. It is almost same the whole day. Okay, and peak load is vary. Okay, so the various peak demands of load over and above base load is known as peak load. Now there are some different load, which is your it may be your domestic load, commercial load, industrial load, base load, and peak load. We have already discussed. So what is your domestic load? So domestic load is everyone knows that the light, fan, refrigerator, heaters, television, small motors for pumping water. Most of the residential load occur only for some hours during the day. That is your domestic load. Okay. For example, lightning load occurs during night time and domestic appliance load occurs for only a few hours. For this reason, the load factor is low. We will discuss about load factor. So, domestic load actually it is not consistent. In day hours, you the whole time you uh, do not require your heaters, television, and small motors. They are used for a particular time of period in a day. And lightning loads basically occur during the night because in India we are getting so much daylight. So we need not any kind of uh, lightning load in day hours. So this is your this load is comes into the category of domestic load. Most of them is residential load, which comes into this category. Next is your commercial load. So this type of load consists of lighting for shops, fan, and electric appliances used in restaurant, etc. So this class of load occurs for more hours during the day as compared to the domestic load. So the commercial load has seasonal variations due to the extensive use of air conditioners and space heaters. So this load is comes into the category of commercial load, which is mostly used in restaurant and companies. So which is like for example, some institutions where your working is from 9 to 5. So they are using fan, ACs, and other load in a daytime. Okay. So this type of load comes into the category of commercial load. Now we come to the industrial load. So industrial load consists of load demand by industries, that how much load you required from the power plant uh, to your industry. So the magnitude of industrial load depends upon the type of industry. It may be small scale industry, large scale industry, or medium scale industry. If you talk about small scale industry, it requires 25 kilowatt load. For medium scale industry, it required 25 kilowatt, more than 25 kilowatt and 100 between 100 kilowatt. And large scale industry requires load above 500 kilowatt. So industrial loads are generally not weather dependent. Okay, so it will depend upon the industry that uh, uh, what what kind of industry it is and how much machine it has and what is the production of this industry. So industrial load is not seasonal. It will depend upon the size of industry. If the industry is a small size, that you require 25 kilowatt. If the industry has medium size, then you require between 25 kilowatt to 100 kilowatt. And if you have large industry, which is required 500 kilowatt load. Now next come to the municipal load. Municipal load consists of street lights, power requirement for water supply, and drainage purpose. So street lightning load is practically constant through the hours of the night. For water supply, water is pumped to overhead tanks by pumps driven by electric motors. Pumping is carried out during the off-peak period. So usually occurring during the night, this helps to improve the load factor of the power system. Okay, so this is the different type of loads. Next is your irrigation load. So this type of load is the electrical power needed for pumps driven by motors to supply water to field. Generally, this type of load is supplied for 12 hours during the night. Traction load, this type of load includes tram cars, trolley, buses, railways, etc. This class of load has wide variation. During the morning hour, it reaches peak value because people have to go their workplace. After morning hours, the load start decreasing and again rise during evening. So since the people start coming to their homes. So there are different kind of load, which load is depending upon the time and when you required the appliances or not. So there are different type of loads which you can classify in different categories. Now, according to this load, the power plant demand is identified, and according to that, the units are used in a power plant. So, type of load curve, there are different type of load curves, which is divided into these seven categories. One is your daily load curve. So, daily load curve means the load variation with time. Okay, the load variation during the whole day, that comes into the daily load curve. Second one is your monthly load curve. So the load curve obtained from the daily load curve is your monthly load curve, and the load curve which is obtained from the monthly load curve is your called yearly load curve. Then your load duration curve, integrated load curve, mass curve, and chronological. In this lecture, we will discuss about load duration curve, mass curve, and chronological curve, because which is very important. So the definition of the load curve. The curve showing the variation of load on the power station with respect to time is called your load curve. And the power demands of different consumers vary in accordance with their activities day to day. So the result of this variation in demand is that the load on a power station is never constant, rather it varies from time to time. So daily load curve can be represented by this graph. In this graph, you can see that the x-axis is representing the time and the y-axis is representing the load. For example, 12 midnight, the load is less than 2 megawatt and it is continuous at 2 a.m. After 2 a.m., it start to increase. At 4 a.m., it reaches 2 megawatt, and after 4 a.m., it is increasing linearly. Okay, at 6 a.m., it reaches 4 megawatt because all people get up early in the morning and they use lightning system, or some in winters they use geyser, and so many equipments are used at this time, so this load increases linearly. After that, the load reaches at its peak, which is greater than 4 megawatt. After you know 7 o'clock, it start decrease, and it continuously decreasing at 10. 10 to 12 is office hours, so load is constant. It is not constant, but it is varying, but a small variation occur. After that, after 12 noon, it again start increasing in summers because everyone turn on their coolers and ACs, refrigerators. So this load is again increasing. After that, it is almost constant, and again it reaches at 6 p.m. it reaches at peak. Again, after 10 p.m. in the night, it is reducing and it become constant almost for 2 or 3 hours. So this is your daily load curve in which you can see that the load variation with hour to hour in a day. Okay. Now, importance of daily load curve. So the daily load curve had attained a great importance in generation. Actually, if we don't know what is our demand, we will not able to set up any power plant. Okay, so these are some important points which we can find out from our daily load curve. So the daily load curve have attained a great importance in generation as they supply the following information. So first is here the daily load curve shows the variation of load on the power station during different hours of the day. The second one, the area under the daily load curve gives the number of units generated in the day. So unit generated per day is equal to the area under the daily load curve. Okay. So from the graph, you can easily find out that how much generation, how much unit is generating by a power plant by calculating the area under the curve. The highest point on the daily load curve represent the maximum demand on the station on that day. So the area under the daily load curve divided by the total number of hours gives the average load on the station in the day. Now we can calculate average load, the area under daily load curve which is divided by 24 hours, then you can easily get the average load. This is the formula of average load which is very important. Now, the load curve helps in selecting the size and numbers of generating units. So the load curve helps in preparing the operation schedule of the station. And the ratio of the area under the load curve to the total area of rectangle in which it is contained gives the load factor. We will discuss about load factor in next slide. Now, let's come to the load duration curve. Okay, we discuss about the daily load curve. We plot the daily load curve between your time and your load. Okay, so the load duration curve is an arrangement of all load levels in a descending order of magnitude. Okay, first you have to take your maximum load, highest load, after that the load which is less than your highest or maximum load, then you have to select these loads in descending orders. So the area under the LDC represents the energy demanded by the system. It can be used in economic dispatching, system planning, and reliability evaluation. It is more convenient to deal with it than the load curve. So from the diagram, you can see that this is your load duration curve. Sorry, this is your load curve and this is your load duration curve. So suppose we are drawing this graph for a particular load. Okay, from 12 midnight to 4 a.m., the load is almost constant, which is 5 megawatt. After 4 to 8, the load is increasing, it becomes 15 megawatt. Then after 8 a.m., 8 to 4, the load is getting 20 megawatt. After 4 p.m., the load is your again 5 megawatt, and in the night it becomes uh, almost zero. Not zero, but load is light. But in load duration curve, you can see that first we are taking peak load. So from this graph, daily load curve, you can see that the 20 megawatt is your maximum load, and this is for your how much hours? This is your 8 hours. Okay, so 0 to 8 hours. This is time of the day, but this is your hours duration. For 8 hours, the load is your 20 megawatt. Then 8 to 12 for 4 hours. After 20, it is 15. Okay. So 4 hours, the load is your 15 megawatt. So 4 hours, the load is your 15 megawatt. Then uh, load is your 5 megawatt for, uh, you know, 12 to 24. So this 12 a.m. to approximate 2 o'clock, this load is your 5 megawatt. So this is the difference between load curve and daily load curve and load duration curve. In daily load curve, you are drawing the graph between the time of day and the um, energy demand of this load, and the load duration curve is drawn between hours duration and the load demand. Okay, so this is the difference between daily curve and load duration curve. Another load duration curve, you can see that for 4 hours the load is your 30 megawatt. You can see that we are arranging this load in descending order. Okay, in descending order, we are taking first your 30 megawatt, then 20 megawatt, then 8 megawatt, then 5 megawatt. And this is time in hours. Okay. So you can see that this is the basic difference between daily load curve and load duration curve. Daily load curve you are drawing according to time of the day, but this is your hours duration. Okay. Now, for one example, we can easily understand the daily load curve and load duration curve. For example, a generation station of 1 megawatt supplied a region which has the following demands. So, from midnight to 5 a.m., it has 100 kilowatt, 5 a.m. to 6 p.m., it has no load, 6 p.m. to 7 p.m. for 1 hour, it is 800 mega kilowatt, and 7 p.m. to 9 p.m. for 2 hours, it is taking 900 kilowatt hour, and 9 p.m. to midnight, the load is your 400 kilowatt. So neglect transmission line losses and find the following. Plot the daily load curve and the load duration curve. So first we have to plot the daily curve. After that we have to plot the load duration curve. Okay. So the table is given from which you can take the time duration and easily draw the load curve. See, this is our daily load curve. So first we have to take time on x-axis, which is 24 hours. Okay, it is from 2 a.m. to 4 a.m. Then on y-axis we are taking the load. Okay, so first is your midnight to 5 a.m. you are using 100 kilowatt. So from midnight to 5 a.m. you are using 100 kilowatt. After that 5 a.m. to 6 p.m. 5 a.m. to 6 p.m. there is no load. So you can see in this graph that 5 a.m. to 6 p.m. Okay, this is your 6 p.m. There is no load. After that, the load is 6 p.m. to 7 p.m. For 1 hour, it is your 800 kilowatt for 1 hour. For 1 hour duration, 6 to 7 p.m., it is 800. Then 9 p.m. to midnight, it is 400 kilowatt. 9 p.m. to midnight. So from 9 p.m. to midnight, it is your 400. Okay, so this is your 400 kilowatt load. So this is your daily load curve. You can easily draw. Now next come to the load duration curve. So I have already told you that load duration curve start from highest to lowest, means descending order. So highest demand of load from the table you can get, this is 900 kilowatt from 7 p.m. to 9 p.m. only for 2 hours. So you can see over here that for 2 hours, you are taking 900 kilowatt. Then from 6 p.m. to 5 a.m. to 6 p.m. there is no load. After 900 you are using 800 kilowatt, which is from 6 p.m. to 7 p.m. only for 1 hour. So you can see that only for 1 hour this is your 800 kilowatt load. Next you are using 400 kilowatt load, which is for 9 p.m. to midnight. So 400 load, this is your 400 load, 4 p.m. to 9 p.m. Okay. Next is your 100, which is from midnight to 5 a.m. So from midnight to 5 a.m. you can easily calculate it. It is 5 hours. So for 5 hours, this load is your 100 kilowatt. So we are taking hourly load over here in load duration curve. So this is the basic difference between your load curve and load duration curve. Now we come to the next point. The following are the information about obtained from load curves. Load duration curve determines the load variation during different hours of the day. It indicates the peak load, which determines the maximum demand on the power station. The area under the load curve gives the total energy generated in the period under consideration. The area under the curve divided by the total numbers of hours gives the load. The ratio of the area under the load curve of the total area of the rectangle in which it is contained gives the load factor. Utility of load curve. The following are the utility of the load curve. Load curve decided decides the installed capacity of a power station. If you don't know how much load you require, then you are not able to generate the electricity. So load curve decide the installed capacity of a power station. It is helpful in choosing the most economical size of the various generating units, because there are different generating units in a power plant. So most economic generation is that you are connecting those generating unit according to your load. Suppose the generating unit capacity is your 500 megawatt, and you have connected only 200 megawatt to this generating unit, then you are not utilizing its full capacity. So from load duration curve, you can divide the units according to your load demand. For 4 hours, that these two units will supply the load. For 3 hours, these particular three units will supply the load. So this is your economically distribution of the units. Okay. Then the load curve estimates the generating cost. It decides the operating schedules of the power station. That is the sequence in which the different generating units should run. Next, we come to the point that is your chronological load curve. It is also important. So there in an average load, we already calculated, or we have seen the formula of average load. How can we calculate the average load? So there is an average load on the power station in a given time period, which could be set depending on the load variation. If this load on the power supply station is plotted against the time, that average load is plotted against the time then in which these load occurs, it gives rise to what is known as chronological. So average load versus time is defined the chronological load curve. Okay, so chronological curve, because of the chronological appearance of the power demand along the time sequence, that's why this is called your chronological load curve. So your yearly load curve or chronological load curve is given here. This is the month of January, February, March, April, May, June. 12 month your load is given here by the help of chronological curve. This is the load in million kilowatt hour. So this is your load chronological curve. Next we come to the point your mass curve. It is very important. So mass curve is basically for drawn hydropower plants. So a mass curve is the plot of accumulated inflow or outflow versus time. Okay, and the mass curve is supply is therefore first drawn and is superimposed by the demand curve. The procedure to construct such diagram is as follows. These are the steps by which you can easily draw the mass curve. So from the past records, determine the hourly demand for all 24 hours. Okay, there are some past record. Then first you have to uh, determine the hourly load, hourly demand for 24 hours. Uh, for typical days, maximum, average, and minimum. What is the maximum requirement in a particular day, and what was the average requirement of that particular day, and what is your minimum requirement of particular day. Then calculate and plot the cumulative demand against time, and thus plot the mass curve of demand. Now read the storage requirement as the sum of the two maximum ordinates between demand and supply. Then repeat the procedure for all the typical days, maximum, average, and mean, and determine the maximum storage required for the worst day. So this is your mass curve. Then in this diagram, you can see that reservoir full at A and B. And this is your mass curve of demand. And this is your mass curve of flow. How much flow you are getting and how much demand you are required. So you need this much of storage for your uh, for reservoir. Okay, so this is your mass curve. Now there are some MCQs which is based on this lecture, and you can easily solve these questions. So first question is, what is the advantage of sectionalizing of power plant? So sectionalizing of power plant is must to get high reliable electricity. So high reliability is the main point for sectionalize of power plants. Next, the area under the load curve represent. The area under the load curve represent the number of units generated. Now, which of the following is equal to the maximum demand? So the ratio of area under to the total area of rectangular, the ratio of area under and number of hours, the peak of load hours, the area under the curve. The peak of load curve, which is defined by the maximum demand, load duration curve indicates the variation of load during different hours of the day, total number of units generated, the given demand, total energy consumed by the load, the number of hours for which the particular load lasts during a day. The variation of load during different hours of the day is represented by your load curve. Now, during which time the demand of electrical energy is maximum. From the diagram, we have already seen that the evening hours you require large amount of energy, which is between from 7 p.m. to 9 p.m. Size and cost of installation depends upon maximum demand. Okay, so how much maximum demand you require? That this way, this is the installation will depend upon this. Thank you. So this is all about this lecture. So I want to summarize this lecture that what we have studied about different loads in this lecture, And the load curve, load duration curve we have drawn. We have taken one example that how can you draw the load curve and what is the importance of your load curve and daily load curve. Okay, so this is all about this lecture. Thank you.